Hello and welcome to another amazing project, and today in this project we are going to conduct how we can detect car number plate using OpenCV and Python. So let's see the demonstration what we are going to build in this project. So after wait for some time, it turned on my webcam, and if I move my mobile screen in front of webcam, as you can see, it start tracking the number plate of this car. And also you can see at left top corner, it only show the car number plate in this window. It successfully detect the car, and if you want to save the car number as an image, then you need to press S. After press S, as you can see, it return a success window and it print plate saved. Before we start our coding, let me introduce you something. This project is part of my Mastering Python OpenCV course on Udemy, and as you can see, it is the new, fresh and bestseller course on Udemy. Till today, it comes with 11.5 hour plus content on it, and it comes with multiple real-world projects. So if you are interested to learn Python OpenCV from the very beginning, I will provide the link in my description. Just check this course on Udemy and you will understand why it has become bestseller. So let's back to the code. Here we need to extract the region of interest area, ROI. We need to extract the number plate area from the footage. For that, we need a cascade file. We need a har cascade file for number plate. So let's jump into the browser. So as you can see, we are in my browser, and here we need to search har cascade Russian plate number. If you search it in a Google, it's going to provide this link. And from this link, you need to download the har cascade file, this file. It is a XML file. If you click on this icon, it's going to download this file in your system. And now we need to move this file, this cascade file, this XML file in my current working directory. So now you can see in my current working directory, we have this file har cascade Russian plate number. And also in my current working directory, I'm going to create a folder. So here I'm going to type plates. And then let's back to the main.py file. So now you might have questioned what is har cascade XML file. Let's try to understand it. This XML file stores all the data that can use to identify a car number plate. It is a pre-trained machine learning model stored in a XML format used to detect specified object with an image like face, eyes, smile, otherwise car number plate and anything. Basically, it is a file that contains the data needed to identify a particular object quickly in an image using OpenCV libraries. And this file is written in XML file format. You cannot understand the points, otherwise the value directly. So let's use it in our main.py file. So at first I'm going to import our main module, which is CV2. So I'm going to type import CV2. Then next I'm going to load the har cascade file in my document. For that I'm going to define a variable, and our variable name is har cascade. Har cascade equal to, inside the double quotes I'm going to provide the file path, and as you can see it is in my current working directory. So just I'm going to copy the file name and I'm going to put it inside the double quotes, and I'm going to type .xml, and I'm going to set this file. Then we need to capture the camera, but I'm going to use live cam. For that I'm going to type cap, it's a variable equal to, here I'm going to initialize with video capture method, cv2 dot video capture, and inside the round braces I'm going to pass 0 here. And now we need to read the frame from the camera using while loop. We need to read all the frame one by one. So here I'm going to type while, and inside the while loop, if our while condition is true, then inside this while loop I want to read all the frame from the camera. So I'm going to type cap dot read method. This read function going to return total two things. First, a boolean value, true either false, and then it's going to return the actual frame we read. To store it in a variable, here we need to define some variable name. And to store the first boolean value, I'm going to type success. And to store the frame, here I'm going to type image, img. Next, we need to load our Her Cascade model. For that, I'm going to define a variable name called plate underscore cascade. Plate cascade equal to load it, I'm going to run a method called cv2.cascade classifier. And inside the round braces, I'm going to pass this variable, Her Cascade. So I copy the variable name and I'm going to put it here. In this method, cascade classifier, we need to pass the Her Cascade classifier file path. And as you know, we already stored it in a variable, Her Cascade. Next, we need to convert this real frame image. It's a colorful image. We need to convert it into grayscale image. For that, here I'm going to define another variable, and our variable name is image img underscore gray. Image gray equal to, we need to use a method called cvt color. cv2.cvt color, and I want to convert it into bgr to gray color. So inside the round braces, first we need to pass the source file, the image source file. So I'm going to pass the frame, the current image frame, img, and then I'm going to convert it cv2.bgr to gray. This one. Remember, by default, OpenCV read our colorful images into BGR color format, blue, green, red, not RGB color format, and you need to remember that. Now, after convert this image into grayscale, we need to detect the number plate area. For that, we need to use a method called detect multiscale. So here I'm going to type plates equal to plate underscore cascade, this variable, dot, and I want to run detect multiscale, this one, this method. Then inside the round braces, at first we need to pass the image. So as image, we need to pass this grayscale image, which is image gray, img gray. Then we need to pass some scale factor. As a scale factor, I'm going to pass 1.1. And for minimum neighborhood value, I'm going to pass 4. The first value, 1.1, stands for scale factor. It specifies how much the image size is reduced at each image pixel. A value 1.1 means the image is reduced by 10% in each iteration. And if I use similar value like 1.05, then it's going to show you more accurate result, but it's going to make your detection very slow. Our next value defines minimum neighborhood, and it specifies how many neighbors a rectangle candidate should have to retain. If I use higher value, it's going to reduce false positive, but it may miss one object. Now you might have questioned what basically it's going to store in this variable or plate variable. This variable going to store list of rectangle. It's going to contain all the rectangle points from frame by frame, and each rectangle represent as x, y, w, and h. Let me explain how it's work. As I told you, detect multiscale return list of rectangles if the card plate is found on this frame, and each of the frame rectangle is represent as x, y, w, h. Suppose this is our camera window resolution, and here we detect a car in this frame, and this is our x-axis direction, this is y-axis direction. And as I told you, x and y represent the top left corner of the rectangle. It's mean this corner. If this is a numbered plate, if we detect the numbered plate, then it's going to represent the top left corner using x-axis and y-axis. So this is our top left corner. Then W represent width of this rectangle, and here you can see in blue color line it is represent the width of this rectangle. I mean the width of the number plate. Then H represent height of the rectangle. Here you can see a red color line, small red color line. It is represent the height of this number plate. So this method going to store this 4 value in this variable for each frame where number plate is detected. Now using this value we are going to draw a real rectangle around this number plate. For that we are going to use for loop. Now let's back to the Visual Studio Code. Now to draw the rectangle in each frame where number plate is found, we need to use for loop. For inside the round braces x, y, w, height in plates. Then inside this for loop, I'm going to create a rectangle. So I'm going to type cv2 dot rectangle. Then inside the round braces, and I want to draw the rectangle in our original image. So I'm going to type img image. Then after comma, first we need to define the starting position of this rectangle. So inside the curly braces, I'm going to pass x-axis and y-axis, x, y. After that we need to define the point 2. I want to say the end point of this rectangle. Here at first we provide the starting point of this rectangle. So I provide the x-axis value and the y-axis value, this corner point. Next we need to provide the end point of this rectangle, this corner value, and we need to calculate it. For that we need to extract the x-axis value. And how we can calculate x-axis value? If I join green line, the green x-axis direction with this blue line, I mean the width of this rectangle, it's going to provide the x-axis value of endpoint. At the same way, for y-axis, if I join this green line with this red line, in that case it's going to return the endpoint of this rectangle at y-axis direction. So we are going to use this calculation to extract the number. So here inside the round braces, I'm going to type x plus width, comma, then I'm going to pass y plus height. So this is the starting corner value of our rectangle and this is the end corner value of our rectangle. After that we need to provide the color. So inside the round braces, and we need to provide the color in BGR format. And I want green color. So I'm going to pass 0, and for green I'm going to use 255, 0. And I want solid color, so I'm going to pass thickness 2. And I'm going to save this file. Then outside the for loop, I'm going to show our rectangle. So I'm going to type cv2 dot show method, show. Then inside the round braces, here I'm going to type image img, our window name is image, and otherwise curve plate, and after comma we need to provide the math light, and here I'm going to pass the image name, image. I want to display this image. After that, here I'm going to use wait key method to destroy all the windows. So type if cv2.waitKey, and I'm going to wait for 1 millisecond, and 0x ss equal to ord. Inside the round braces, if I type q, then I want to break this loop, break. After break this loop, I'm going to, outside this if condition, I'm going to destroy all the windows. Also I'm going to release the camera. So I'm going to type cap.release method, release. And also I'm going to destroy all the windows, so I'm going to type cv2.destroy all windows, this one. And I'm going to save this file. Now let's save the file and run this code in my terminal. Let's see, is it work properly or not. So I hit run button and I need to wait for some time to start our webcam. So hi, this is me and it's already opened my webcam. And I don't have car in front of my webcam. So here I open a car license plate image in my mobile. And if I move it to my webcam, now you can see it successfully detect the car license plate number. So our program identified the car number plate successfully. And if I press Q, then it's going to quit the program. So this is the first part of this tutorial. At that section, we learn how we can detect the car number plate. At the next part of this tutorial, we are going to extract the area and we need to save this area as an image file format in a folder. So thanks for watching this video. Stay tuned for our next part. Good to see you back, guys. This is the another tutorial related our project. And we are going to start our project to adding text in our rectangle. I want to say the outside the rectangle. So here I'm going to type inside the for loop cv2 dot put text method. Put text. Then inside the round braces, and I want to put text in image frame. So I'm going to type img, comma, then we need to provide the exact text which I want to show in our window. And I'm going to type number plate. Then after comma, here I'm going to type x, comma, I'm going to define the position. So for origin position, I'm going to pass x and y axis, x, comma, y minus 5. Why I pass y minus 5? Because I want to put it above the border line. That's why here I pass minus 5. So after define the position, then we need to define the font face. Which font we are going to use? So I'm going to type cv2 dot font Hershey complex small, this one. Then we need to define the font scale. I'm going to pass 1. Next we need to define the color, the font color, and I'm going to pass 255 for blue color. For green I'm going to pass 0, and for the red I'm going to pass 255 again. Next we need to provide the thickness, and I'm going to pass 2, and I'm going to save this file. Now after save this file, if I run this code in my terminal, we need to wait for some time to start the program. So after wait for some time, as you can see, it start my webcam. And I already opened car number plate image in my mobile. And if I move my screen in front of camera, as you can see, it detect the car license plate. And also you can notice a text above the rectangle, number plate. So I successfully put the text above the rectangle. Now let's back to the program. So I'm going to press Q command to quit the program. Now after that, I want to display in a different window those area which is inside the rectangle. Let me show you what I want to say. So here I'm going to type region of interest, image img underscore ROI. ROI stands for region of interest, equal to, here I am going to crop the image. So I'm going to type img, inside the square braces we need to define the position, the cropping position. So I'm going to type y colon y plus height, comma, this is for height, and for width I'm going to type x colon x plus width w. It is not ing, it's img. Basically it is the image cropping technique, and it's going to select those rectangle area, the exact rectangle area, and then I want to display this rectangle area in an window. So I'm going to type cv2 dot IamShow method, IamShow. Then inside the round braces, inside the double quotes, first I'm going to type, for this window I'm going to type ROI. It's mean region of interest, comma, and then we need to provide the actual image frame. So I'm going to pass img ROI. Now if I save this file and run this code in my terminal, it's going to show you another window where it's going to show only the rectangle area image. So after save the file, if I run this code in my terminal, so after wait for some time, it opened my webcam. And if I move the car number plate image in front of camera, here you can notice it detects the number plate, also it displays the number plate in a different window. And the window size is exact size of rectangle. So it's worked successfully. Now let's back to the code. And now we need to save this crop image in a different image in this folder. Plates. I want to save the image. For that, I'm going to create a if condition. So I'm going to duplicate this section. Then I'm going to type S. So if I press S, then I want to save this image file in a directory. I want to save these image files in this folder plates. And as you know, to create an image, we need to use imWrite method. So I'm going to type cv2.imWrite. Then inside the round braces, at first we need to provide the folder name, the file path where I'm going to save the files. So I'm going to type plates. First I'm going to provide the folder name plates / and then we need to provide the image name. So I'm going to type car _ plate. After that, I'm going to use concatenation sign. And again I'm going to use another concatenation sign. Then I'm going to type the file extension. I want to save this file in JPG format, so I'm going to type .jpg. Here inside the concatenation sign, we need to increment the number. Suppose if I scan multiple image, in that case I'm going to save this image as carplate.0.jpg, and again I'm going to save this image carplate.1.jpg, then 2, then 3. So here we need to increment the value after every iteration. So before the while loop, here I'm going to declare a variable called count. Count equal to, for now I'm going to initialize with 0. Then I'm going to pass count here. Also I'm going to convert this variable into string, so here I'm going to pass str string method. So after save the file path, after define the file path, then we need to define the image. So here I'm going to pass, and I want to save the image from image img _ region of interest, this one. Basically after detect the number plate, if I press Q, then it's going to close our program. But if I press S, then it's going to save the file in my directory, this folder, plates. Next, I want to show a successful message in a different window. For that, I am going to create a rectangle. So to create the rectangle, I'm going to type cv2.rectangle method. And inside the round braces, at first we need to define the image, in which image I want to create the rectangles. So I'm going to type img. After that, we need to define the first point of the rectangle from where I want to start the rectangle. So for x-axis I'm going to type 0, and for the y-axis I'm going to pass 200. From this point I want to start the rectangle. Then we need to define the end point of this rectangle. So I'm going to pass, for x-axis I'm going to pass 640, and for y-axis I'm going to pass 300. Then we need to define the color of the rectangle. So inside the round braces, I'm going to define color 0, B equal to 0, G equal to 255, for red I'm going to use 0 again. And then I'm going to pass the thickness. So I want to fill this rectangle with color, so I'm going to pass cv2 dot filled it. It's going to fill this rectangle with this color, and here I use green color. Then after create the rectangle, we need to put a text, we need to pass the success message inside this rectangle. For that, I'm going to use put text method, cv2 dot put text. Then inside the round braces, at first I'm going to pass the image source in which image I want to put the text, which is img. Then we need to pass the text. So I'm going to type success. So here I'm going to type. So here I'm going to. Then here we need to pass the success message. So as a success message, I'm going to type plate set. Then we need to define the position of this text, from where I want to start our text. So for x-axis, I'm going to pass 150, and for the y-axis, I'm going to pass 265. Next, we need to define the font style, and I'm going to use the same font. So I copy this section and I'm going to paste it here. After that, we need to define the font scale, and I'm going to pass 2. I want little bigger font than previous one. Then we need to define the color of this font. So I'm going to pass 0, 0, 255. Here I use red color. And then I'm going to provide the thickness of this font, and I'm going to use 2. That's it. And also we need to display this image in a different window. So here I'm going to type cv2.imageShow method, image show. Then inside the round braces, here I'm going to type success, and then we need to pass the source image img. And next I'm going to wait for, after press S, I want to wait for 500 milliseconds, because we need to provide time to save the image file in a folder. So I'm going to type cv2 dot wait key function, wait key method. Then inside the round braces, I'm going to wait for 500 milliseconds. After that, we need to increment this count variable after every iteration. So every time I press S, it's going to increment the value. So I'm going to type count plus equal to 1. Every time it's going to increment this value with 1, and I'm going to set this file. So we are done. Now let's run the code in my terminal and see is it work properly or not. So after run this code in my terminal, I'm going to wait for to start our webcam. So after wait for some time, it turn on my webcam. And if I move my mobile screen in front of webcam, as you can see, it start tracking the number plate of this car. And also you can see at left top corner, it only show the car number plate in this window. It successfully detect the car. And if you want to save the car number as an image, then you need to press S. After press S, as you can see, it return a success window and it print plate saved. And if you want to close the program, then you need to press Q. After press Q in your keyboard, it's going to kill the program. Now if I jump into the plate directory, plates, now you can see an image, car underscore plate 0.jpg. If I open this image, you can see the result. This is our car number plate. So as you can see, it set the car number plate in this folder, plates. So as you can see how we can detect car number plate using LiveCam. And also we extract the car number plate image and save it in a different folder. So this is it for this tutorial. At the next tutorial, we are going to extract the number using OCR. And if you don't want to apply OCR to extract the number, you can go with this program. So thanks for watching this video. Stay tuned for our next project.